So we are in section 10.2 today, which is about circles. We're going to go ahead and start with parts of a circle. So the radius is a segment that stretches from the center of the circle to a point on the boundary of the circle. I'm going to label these as we go. So this part is the radius, and the radius is labeled with a lowercase r. The diameter is twice the radius and is a segment that stretches from one point of the circle to another point on the circle and passes through the center of the circle. So this is the diameter, and the diameter is represented with the lowercase d. And then just a reminder, the diameter is twice the value of the radius. The circumference is the distance around the boundary of a circle. So this is the circumference. And the circumference is usually referred to as a capital C. So in our equations, capital C is circumference. Circles are named using the center point of the circle. And we do write this in two ways. The first is what you're going to see in your notes. So I have circle, like literally the word circle, and then the center point. So I have circle W. You might also see notation where you have a circle with a dot in the middle, and then the center point next to it. And that would also read as circle W. Just to be straightforward with you, I could not figure out how to type that, so I'm not using that notation at all. We're just going to continue with the word circle and the point. Okay. So center of the circle, radius, diameter, circumference. You really should have used all of these words before. How much time you spent with them, that's going to be a different question. So we have two things that we can calculate right now. The area of the circle, area equals pi times the radius squared, and the circumference of the circle, which is c equals 2 pi r. Or, I didn't put this one in our slides here, but the other option for circumference is pi times the diameter, because the diameter is equal to twice the radius. So d and 2r are the same thing. Okay. I really don't care which of these formulas you're using, if it's 2 pi r or pi times the diameter. If there's an option, sometimes you'll only have the radius, so you're going to be multiplying it by 2 if you're using the diameter anyway. If you only have the diameter, then you don't need to find the radius, but sometimes you might need the radius to solve other things. So it's just going to kind of depend on what you're doing. In example 1, it says to find the area of and circumference of the circle. Give your answer as a decimal and in terms of pi. So let's go ahead and start with area. Area of a circle is equal to pi times the radius squared. In this circle, what is the radius? 7. So we have 7 squared, which is 49 times pi. Now we're going to type that into our calculators. This is part of, oh, my battery is low. I'm going to put my calculator on the screen, and hopefully it won't die. When we type these, in the past, you have probably used 3.14. So you would have done 49 times 3.14 like that to get 153.86. We are not going to use 3.14. We are going to use the pi button. So on your calculator, you're going to press the second button and then the caret key, which is barely on the screen in the bottom right corner. That caret key is the little up arrow, not the keypad arrows, but this one next to tangent. That has pi in blue. So when we hit second, it selects the pi symbol. So when we use 49 with the pi symbol, it actually changes the decimal just a little bit. It's not a lot, but that difference can sometimes make a big deal. So we have 153.94. I'm going to switch back to our slides. And then area, our units for this one will be square feet. So this is your answer in terms of decimals. Your answer in terms of pi is this right here. Terms of pi means that we are leaving pi in the equation, like that. So those will be your two answers. Now we're going to find the circumference of the circle. We're going to do the same thing. So I have circumference equals 2 times pi times the radius, which we know is 7. 2 times 7 is equal to 14. So in terms of pi, circumference is 14 pi feet. Because remember, circumference is the distance around the circle. So that is not square units. That's essentially like if you took a segment and stretched it around a circle. So this is a length. All right. And then as a decimal, we're going to type 14 and then pi. We get 43.98 feet. Example 2. A circle has a circumference of 24 pi. Find its area. So on this question, I'm going to write out the circumference formula. We have 2 pi r. We're trying to find its area. So the area formula, area equals pi r squared. In order to find the area, we need to know the radius. So we need to work backwards from the circumference to find the radius. So I know that I have a radius of 24 pi. So I'm going to plug that into my circumference formula in place of c, which stands for circumference. So 24 pi is equal to 2 pi times the radius. To solve for the radius here, I am actually going to divide out 2 and pi at the same time. We're going to just travel together here. This is where terms of pi is kind of nice, because on the right side of this equation, 2 and pi cancel out. On the left side, the pi's cancel out. 24 divided by 2 is equal to 12, so we know that the radius is 12. Now that we know our radius, we can find our area. So I'm going to take that value of the radius and plug it into my equation in place of r. So area is equal to pi times the radius squared. So I have 144 times pi, because 12 squared is 144. And then because it does not specify to leave your answer in terms of pi, we're going to go with decimals. So anytime it does not specify, decimals is what we want. So I've got 452.39. And I did not give you any units on that one, so we're just going to leave it as is. Or you could. Next we have arcs. A central angle is an angle formed by 2 radii whose vertex is the center of the circle. So this circle right here has an angle inside the circle, so that P, being the center of the circle, is the vertex of the angle. And then these 2 sides of the angle start on the vertex and end on the circle. So then we have, I'm just going to label this as we go here, this as our central angle. An intercepted arc is the part of a circle that lies between the two segments, rays, or lines that intersect a circle. So this distance right here is the intercepted arc. A sector is the region bounded by a central angle and its intercepted arc. So this space right here is our sector. If the endpoints of an arc lie on a diameter, the arc is called a semicircle. In this case, we do not have a semicircle. That is another way of saying half a circle. But we do have a minor arc. A minor arc is smaller than a semicircle. So this intercepted arc right here is also a minor arc. And if we have a minor arc, then you would expect that we would have a major arc. A major arc is larger than a semicircle. So this distance around the circle, essentially the long way, that is the major arc. Okay, so those are the pieces. Now we're going to talk about how we name them and how we write the names. So the central angle, that's just the same angle notation that we've been using. So angle APB is a central angle. We've done that. We've seen it. An arc is pretty similar to how we were naming segments, lines, rays, opposite rays, that type of thing. Whereas if you remember, I'm just going to use the points that we have here. For AB, if it was a segment, you just have the solid line. If it's a ray, you have a line with one arrow. If it's a line, you have the bar with two arrows. Same type of idea, but we're working with arcs. So what do you think goes on top of the letters? Yeah, a curve, an arc. Arc, AB. The other way we might write that is with the word arc, like so, which is what you're going to see most of because I did not figure out how to type the arc either. So this is mostly what you're going to see. Anytime I'm handwriting something, it's going to be written like this though. So our minor arc here, we have arc AB. That's our minor arc. The major arc, this one's where it changes up a little bit. When it's a minor arc, we use 2 points. When it's a major arc, we use 3. So the major arc is A, C, B. And we put an arc across that whole thing, ACB. One last thing about arcs. The degree measure of an arc is equal to the measure of its central angle. So we have this central angle right here, angle APB, and we say the measure of angle APB is equal to 95 degrees. Arcs work in a very similar way, except we don't put the angle sign with it because it's not an angle, it's an arc. So for the arc, we have the measure of arc AB is equal to 95 degrees. So in example 3 here, now we're going to name the things that we just learned about. So part A, name the central angle. Close. angle XWZ. We got there. Okay. No, you said Y instead. That's all right. Okay. Name the minor arc. What's the minor arc here? XZ. And then don't forget when you're writing it, you either need to write the word arc before it or draw the arc on top. Then what's the major arc? XYZ. Same thing, either write the word arc before it or make sure you put the arc on top of those 3 points. What is the measure of arc XZ? 115 degrees. Because it's the same as the central angle. So then what do you think is going to happen for the measure of arc XYZ? We're going to do 360 minus 115. And that gives us that the measure of arc XYZ is equal to, does anyone have it? 245 degrees. We're now going to take a look at area and arc length, sector area and arc length. So the first question here is, how much of this circle is shaded? 1/4. And we know that for a couple different reasons, but 90 degrees out of 360 degrees is 1/4. So if 1/4 of the circle is shaded, then what do you think is going to happen with the area?
Oh, it's going to be 1/4 of the total area.
Yeah, it's going to be 1/4 of the total area. So you have the circle area times 1/4. What about the minor arc length? It's going to be 1/4 of the circumference.
Supposed to be taking down this doesn't have a spot.
That's this box. I just formatted it a little differently.
Should I answer its actual questions or should I just write?
In general, here's our formula. For sector area, we have pi times the radius squared times theta over 360.
Yep.
Arc length, we have 2 times pi times r times theta over 360. So I'll answer the question now. Theta is a Greek letter that we use in math to notate or represent an angle measure, sometimes in degrees, sometimes in radians. We haven't really talked about radians, I just mentioned it once before, but either way, that means that it's an angle measure. So theta is the given measure of the circle sector. Example 4 says to find the area and arc length of the shaded region. So let's start with area. Area is equal to pi times the radius squared. Becca, what's the radius? 12? Okay, couldn't hear you. 12 squared times the degrees, 131, out of 360. So we have 144 for 12 squared. 131 over 360 is not going to reduce, so we can't reduce it. So 131 over 360 is how we're going to leave it. What that does mean is we're going to type this into our calculator. If it was terms of pi, we would leave it as is. We want decimals, so we're also going to multiply it by pi in our calculator. And I'm just going to do that real quick. So I've got 144 times 131 divided by 360 times pi gives me 164.62. And that would be square meters. And just to be clear, I only wrote A for area because it is area, but it is sector area. Now we have arc length. 2 times pi times the radius, which we know is 12, times the degrees we have, 131 out of 360. So now we're going to multiply this out. So I have pi times 24 times 131 over 360. And I'm going to type that all in my calculator in just a moment here. So I have arc length will be equal to, let's find out what it is. We've got 24 times 131 divided by 360 times pi, which gives me 27.44 meters. And then we had two answers: sector area and arc length. Okay. Example 5. Find the length of arc GH in the figure below. So we again are looking at arc length. This time we have 2 times pi times what? 6 times what comes next? 40 out of 360. All right. So this one, we actually can simplify a little bit, and it's going to make math a little easier, our math easier. So 2 times 6 is 12. So I have pi times 12. The 0 from the 40 and the 360 cancels out. Essentially, you're dividing both by 10. 4 actually multiplies into 36 9 times. So that's 1/9. 12 and 9 are both divisible by 3 because we really have 12/9 now. So we really have 4/3 pi. If we were writing our answer in terms of pi, you would need that reduced fraction, or you would need the decimal that is equal to. We are looking for the decimal, so we're going to type into our calculator 4/3 times pi, and that does give us 4.19. So arc length equals 4.19 meters. And I did not mention this on the other one, but when we're solving arc length, you could, instead of writing arc length, and this really would be the better choice here, we can just use the arc name. So I can say arc GH, and this time we don't put the M in front because the M was for the arc degree. This is for the arc length. So it's just arc GH is equal to 4.19 meters. In example 6, we have the minute hand of a clock with a radius of 9 centimeters moves from the 12 to the 4. What is the distance traveled by the tip of the minute hand? So here's a circle for our clock. This is an analog clock. I know some of you are not super familiar with those. So the very first thing we're going to do is fill in our clock. So we've got 12, 6, 3, 9, and then to fill in the missing pieces, I'm going around in thirds. And then we'd have the center. The minute hand of a clock is the longer hand. Our minute hand has a radius of 9 centimeters. So it is 9 centimeters long and is traveling from the 12 to the 4. If it's helpful, we'll make this one dotted. Okay. So, whoops. Okay. So now that we have this visual here to help us out, arc length is what we're looking for because this is asking for distance. That keyword distance is what fills me in that this is arc length. We also do not have names for our arc. So arc length is how we're going to leave it. We're going to use the same formula. So we have 2 times pi times the radius, which we know to be 9, times previously we had the degrees out of a total 360 degrees. We don't have degrees for this clock. Could we figure them out? Yes. We are not going to need them because we know that we went from 12 to 4. So we went 1, 2, 3, 4 spaces out of how many? 12. It doesn't really matter what the fraction is on the end as long as it is correctly giving the amount traveled out of the whole. So in this case, we are counting by hours, not degrees. So then we have pi times 2 times 9 is 18. 4 over 12 reduces down to 1/3. 18 divided by 3 is equal to 6. So I have 6 pi as my arc length. I'm going to type that into my calculator, and that gives me that my distance is 18.85 centimeters. And that is what we're looking for. This is where we're going to stop our notes for today.